In this problem, we'll use the properties of logarithms to find the derivative of f of x. First, let's rewrite the expression so it isn't a fraction. We can do this because we have a rule, called the logarithm quotient rule, that says the logarithm of a fraction is equal to the logarithm of the numerator minus the logarithm of the denominator. So we can write f of x equals log base 5 of the quantity 2x to the 7th power minus 4x plus 1 minus log base 5 of the quantity x cubed times the quantity 5x squared minus 3. Next, let's look closely at the second term. There is another rule for logarithms called the logarithm product rule. That states that the logarithm of a product is equal to the sum of the logarithms of the factors. So let's rewrite the second term with this in mind. Remember that the new sum is being subtracted from the first logarithmic term, so distribute the negative sign throughout. We now have f of x equals log base 5 of the quantity 2x to the 7th power minus 4x plus 1 minus log base 5 of x cubed minus log base 5 of the quantity 5x squared minus 3. We can simplify the middle term further. Another property of logarithms, called the logarithm power rule, states that the logarithm of a value to a power is equal to the value of the exponent times the logarithm of the base. This means we can write the second term as 3 times log base 5 of x. Now we have the function in the form log base b of g of x, which means we can now take the derivative of each term to find f prime of x. To take the derivative of a logarithm, we first take the derivative of the argument, which is the value inside the parentheses following the base. We then multiply this derivative by 1 over the argument times 1 over the natural log of the base and simplify. For the first term, we get 14x to the 6th power minus 4 for the derivative of the argument over the quantity 2x to the 7th power minus 4x plus 1 times the natural log of 5. Next, we'll look at the second term. Following the same process, we get minus 3 over x times the natural log of 5. Since the derivative of x is just 1, we are only left with 3 in the numerator. Finally, we'll use this process again for the third term. The derivative of the argument is 10x, so that will be our numerator. So we have minus 10x over the quantity 5x squared minus 3 times the natural log of 5.